My name is Patrick Cavanaugh, and I'm joined with special guest Dr. Jim Adaskaveg from the University of California Riverside, Elaine Trevino with the Almond Alliance, and Joe Vassios, Technical Service Lead with Specialty Crops for UPL. Jim, Elaine, and Joe, will you introduce yourself and tell us about your current role in the industry?
Hi, I'm Jim Adaskaveg. Nice to be here today. Thank you, Patrick, for that introduction. I'm a professor here at the University of California, Riverside, and I do a lot of research on plant pathology for the commodity boards like the Almond Board of California. I've been studying diseases for over 30 years of tree crops, and so my experience is both with fungal and bacterial diseases of almonds in this case.
Hi, my name is Elaine Trevino. I'm the president of the Almond Alliance. We are the trade association for the almond industry, California almond industry. We're made up of processors, wholer shellers, and growers statewide. And we serve as basically the voice of the almond industry in all political areas and the regulatory front, both on the federal and state levels. And we continue to advocate on behalf of the industry on issues pertaining to water, grower issues, pesticide issues, trade, again, regulatory, or anything that impedes the operations of the almond industry.
I'm Joe Vassios. I'm a technical service lead for UPL North America. I'm based in Sacramento, California. I've got responsibility for managing UPL's technical service team and all the specialty crop growing regions around the US. As well as managing my own territory within Northern California, where we work with our sales team and researchers to implement new technologies for growers across the state.
Thanks for joining us. Today, we're talking about bacterial blast in almonds. So, Jim, what can you tell us about this disease?
Well, bacterial blast is a bacterial disease, and with plant pathology, we deal with microorganisms, fungi and bacteria, viruses. These are all microorganisms that you can't really see until they actually cause the disease. This particular disease is a disease of cold, wet conditions, uh, cold, wet environments, even if it's microclimates like a orchard that's down in a valley. So we see this disease as a opportunistic type of disease. The pathogen is ubiquitous, living on the surface of trees, all parts of trees, flowers, branches, leaves. And when those conditions, wet, cold environments occur, the tree is kind of like stunted and stressed, and the bacteria takes advantage of that situation. So the disease can be very destructive. It can affect blossoms, it can affect spurs, leaves, and even branches can die back from bacterial blast. And so blast just means it's the wilting of the flower or wilting of the leaf shoots and causing some death. And so it's not really, there's no fungal sporulation like we see with other diseases like brown rot or botrytis. So what we look for is the lack of those types. So to diagnose it, we look for the lack of those types of symptoms and signs of the pathogen. And we just see no fungal tissue, no fungal sporulation, and then we see a blasted, diseased flower.
Interesting, Jim. What kind of impact can almond growers expect from bacterial blast in almonds?
Well, the disease is very sporadic, and it's really based on those wet, cold conditions that exist in the orchard. And so we can go from very not having any disease, and because the bacterium is ubiquitous, living on the tree on the surface of the tree as an epiphyte, waiting for these opportunities to get into the tree, it can be really devastating if we get cold, wet weather right during bloom. And some of the information that we've gathered for helping to get this registered, some of our new products that we're testing, is that we can see up to 40% crop loss, infection, actually crop loss. Sometimes we get 50% blasted flowers. And then we actually go back and measure the yields, and because not every flower results in a almond nut, it basically, we can see that there's huge losses between 30 and 40%. And we compare these over the years where they didn't have this in that particular orchard, and we can come up with the estimates of crop loss. So it's one of those diseases that if you have an orchard that's in a location that's prone to the right conditions for the disease, you can get extensive losses. And then next year it might be not there, but you're left with the dieback, the dropped leaves, that you're left with those impacts on your orchard.
So Jim, when should the growers or PCAs be looking for symptoms of bacterial blast or preventing bacterial blast?
So basically what we're trying to do is do a preventative treatments. And so the time of year that you would see blast in California, and it's different in different locations because we have different times and climate conditions. But in California, growing almonds, what we would find is when we get cold, wet weather, frost conditions. So those are the conditions that you need to put the preventative treatments on ahead of time. What happens is if you didn't do that, you would wait probably within 7 to 14 days after, say, a frost event, that during the bloom period or early leaf stage, during those timings of from February to early March, when we do get these kinds of conditions in California, and you would wait 2 to 3 weeks after that to see the typical symptoms that I am explaining of branch dieback, blasted flowers, and that type of effects on the tree.
So Jim, what are the new options available for growers?
Well, one of the new options for growers, Patrick, is that we've been doing research on managing not only fungal diseases, but bacterial diseases of tree crops. And so we've been looking for new materials. And so fortunately, we've identified a product called Curcumin, and that product is been tested on many different bacterial diseases of tree crops. So it's now registered. We worked with UPL to identify this material, do all the efficacy testing. We nominated it into the federal IR4 program to get it, get the residue data so that we can register it. And we did this we started with pome fruit for fire blight, and we expanded this to walnuts and cherries. And so now there's currently registrations on all those crops for this bactericide. And so we, as this process is going, we nominated almonds to be also a crop on the label for Curcumin. And so this material has been evaluated against a lot of bacterial diseases of tree crops. And we've been fortunate to show that it's very efficacious on the pathogen of bacterial blast of almond caused by Pseudomonas syringae. So that's one of the things that we help the almond industry, is to identify these new types of products, new technology that's available that can be used to help solve problems in the immediate sense of what can a grower do. A frost is forecasted. What's the grower going to do to manage that disease?
So Jim, a lot of growers are looking at copper for bacterial blast.
Well, that's a natural response because copper has been used as a bactericide on many crops. Unfortunately, copper can be phytotoxic to almond and cause leaf spots and flowers to drop, and leaves actually to fall off the tree or defoliate the tree. So if you use copper, it has to be done early during the delayed dormant or dormant period. But then the disease, because the plant is producing a lot of the new flowers and the leaves are emerging, these tissues, because copper is not systemic, these tissues are then still not protected. And if you apply copper to those young tissues, it could cause damage. And so copper has not been an alternative treatment for managing bacterial blast on almonds. Additionally, we tested a lot of these a lot of the different crops Pseudomonas syringae occurs on, including almonds and cherries and many of these other crops. And what we find is most of the populations are resistant to copper. And so this is another negative aspect. You put on a treatment expecting it to work, and the pathogen is not sensitive to that treatment. And so unfortunately, copper has not been an alternative treatment available to growers.
So Jim, tell us about a new product that could be available for growers coming up this season.
Well, we've been testing the bactericide Cassumin for a number of years, and we're really excited about it. It has high efficacy on many of the bacterial diseases of tree crops. And so we have the experience and registration process for many of the other crops, including pome fruit, apple and pears, walnuts and cherries. And during that process, we also recognized that almonds had this particular problem, bacterial blast caused by this disease pathogen, Pseudomonas syringae. So what we did was we applied for this to go through the IR4 program. It's a federal program that does the residue work, and it allows companies to endorse a registration with, while it's a real need, it might not be a high market, but that's the part of the process of the IR4 program, is to get specialty crop registrations, maybe for niche markets. And so this particular thing fit the bill for almonds. And so we applied for the Section 3 through the IR4 program. This is the normal registration process, and it's been at the EPA for over a year and a half now. And so that process is ongoing. In the meantime, as of back in 2019, there was a lot of growers that had cold damage, frost damage, and bacterial blasts took over and caused a lot of damage in some of those orchards. And so what we did in 2019 is we applied for a Section 18, which is an emergency registration exemption. This is a legal document process that allows growers and grower groups to, if you have a treatment and you have a problem in your orchard where you're losing a significant amount of crop, you can apply for the Section 18. And we were fortunate enough to do this, and it was accepted in for the 2020 season as of last February. Unfortunately, it's an annual process. And so even though the Section 3 is still ongoing at EPA, that process to get fully registration of that particular Cassumin bactericide, we have to apply for a Section 18 again for the 2021 season. And so that's where we are. We submitted that Section 18 petition with Elaine Trevino, and she's with the Almond Alliance. And we've worked with that group in order to officially submit this to the state and to the EPA, the federal EPA level.
Elaine, can you tell us more about the process of submitting a Section 18 emergency exemption? What's that like?
Yes, absolutely. I'll take a second just to explain what the Section 18 of FIFRA is, for those that aren't fully aware of how this works. And so basically what we know is the Section 18s for unregistered use of pesticides to address emergency conditions. Under this exemption, EPA allows a limited use of a pesticide given that it's defined urgent. And how is that done? Well, that's quite a process, but I will try to give you the short version here. That you have to identify and define your emergency condition and situation. It has to be urgent, non-routine situation that requires this use. And EPA then assesses the risk to human health and the environment. So types of exemptions, they range, but the most common is to show a significant economic loss or a significant risk to the environment, which may include a risk to, of course, crop or endangered or threatened species or beneficial organisms. So EPA then takes your application and they look at, they evaluate, and they have about 45 days in which to do so. So there are several criteria that they examine, and everything, including the economic loss, the risks to human health, the risk to the workforce, those surrounding the area, ecological risks through environmental exposures, as well as any public health risk. So what's the process? Basically, it requires the cooperation of the registrant, the extension agent, like someone like Jim from the UC Extension that you heard from, to document the damage to the industry, and then a trade association or grower group like ourselves, the Almond Alliance, which basically further demonstrates why this is problematic to the industry if it's not granted. We have to address the history or the pathway of the disease. Our application has to include interim use. We have to outline the current registration process and progress. We have to provide specific details about the pest or bacteria that's being addressed. And then we have to identify the amount of the product that's proposed to be used, the acres to be treated, the estimate of effectiveness, any adverse, again, effects or impacts. On the economic loss section, we have to talk about the yields per acre impact, the price per unit, and the gross revenue impact. So as you can see, it's a pretty detailed analysis that has to be done. And then again, we work with DPR, with UC Extension, with the registrant, and ourselves, providing letters of support and also analysis of why this is critical. So you have to identify many things, come together, timing of harvest, and you hope that the material you're asking for the exemption for is being used in other crops, so it's just not you coming to the table. But that's a little bit of a summary. The final part is you have to get the sign off of your ag commissioner, and then of course submit it to DPR so they can submit to APA.
Well, Jim, can you tell us why it's important for new technologies to be approved for this exemption?
Well, new technologies are very important for the almond industry. We're all concerned about pesticides and the potential of contamination of the environment. And so some of the older bactericides that we've registered in over time have been impact the environment and impact orchards and can impact the almond production. So what we've done is we've tried to identify new technologies and new chemistries such as kasugamycin. And this is it has a technical name known as an antibiotic, but we call it a bactericide because it's not used in human or animal medicine. So it kind of makes a distinction from other types of antibiotics that are used in human disease management and human diseases and animal diseases. So we use these different terminologies to try to demonstrate that this material is different from other materials. And so this new technology is very important because it doesn't have the persistence. You put it on and it doesn't last and impact the environment weeks later. It has a very short, what we call in pesticide, a very short residual lifespan. And so this is part of why we want these new technologies. It also doesn't impact other organisms. So what we're trying to do is target the exact organism that we're trying to manage. So this new technology isn't going to impact other natural fungi that might be beneficial or other microorganisms that might be beneficial to almond production. And so these are very targeted new technologies, and they don't persist in the environment. And their toxicology is such that they're not going to be harmful to people. And so they're, because I mentioned that they have short lifespans, and we're putting them on during bloom and shortly after bloom and during the early fruit development when frost can be a damaging environmental impact, then by the time they harvest the crop, there's no residues left. And this is what we've demonstrated with the IR4 residue program. And so this means that the chances of people being exposed to these materials in this new technology of chemistry means that we use those materials and then they're effectively gone a month later, and there's no potential for human exposure by the time the crop is harvested.
Joe, Kassuman has become an important tool for California growers. Can you tell me a little more about Kassuman and its benefits to growers in California?
Absolutely, Patrick. So as Jim has mentioned, Kassuman's been registered now in California for several years. Initially, those registrations were on apples and pears for fire blight on the palm fruit. More recently, Jim alluded to as well, the use on cherries, and then also as a tool for walnut blight. Some of these attributes of the product have made it very beneficial for the growers, including the fact, like Jim mentioned, it's a very targeted antibiotic class. We don't see any cross resistance with other products that have shown some resistance at different levels in some of these diseases, such as streptomycin or copper products. So being a novel mode of action with no cross resistance has been very beneficial. Another thing that I did want to point out to one of Jim's points is that, in addition to being very specific to these bacteria, also, we've shown very minimal impacts on any of the pollinators. So with this going out during bloom time, we know that pollinator safety is top of mind for all growers. So I think it's something else important to point out that, it's been shown to pose a very minimal risk to any of those pollinators as well. In terms of the Section 18 on almonds and our continued work with that, UPL has really provided a supportive role in providing support to Jim and to Elaine where needed. That's something that they've really spearheaded and done this for the almond industry of California. And, we really have appreciated their efforts on this and then being a part of that process and bringing this tool for growers here in California as well. So I look forward to working with Jim, Elaine, and all the other researchers and industry associations on continuing to grow Kassuman for other markets where it might have a fit here in California.
So Jim, do you have any final points to leave our listeners with?
Well, we're excited about Kassuman. We never had a tool that was so effective and versatile as Kassuman. So we're excited about this new treatment. The big take-home message is that if you see the symptoms of the disease, it's too late. So like many other diseases on tree crops, everything is preventative. So you have to apply these materials going into a frost event. Unfortunately, our weather forecasting, we can predict frosts within pretty much 7 days of their occurrence, and that time will be ample enough to get growers to go out and make the application. So we're very proactive on timing these things with the environmental conditions, and if the environmental conditions don't exist, we don't need to make these applications of Kassuman. So we need to be very aware of the environmental conditions and be proactive when we get a forecast to be out there and applying the material as needed as a preventative treatment.
Thank you, Jim, Elaine, and Joe for joining me today to talk about that important disease of bacterial blast in almonds. Enjoy the rest of the almond conference.